Hello everybody, it's old Shazizz here. Excuse the mess. My mad science laboratory has been crowded into my room here, so it's just a mess. Anyway, what you're looking at is a Franklin bell, my version of a Franklin bell. If you look real close in there, you should be able to see on that lid that I drilled the hole through this lid of this container and made a little U-shaped deal there for a loop in a piece of copper wire to hold that ball in there. Also inside there I have a donut shaped piece of aluminum foil just to kind of help with the process a little bit. What a doggone mess, man. Alright, you can see on this side I've got aluminum tape going down. On the inside I've got aluminum tape going down. That's my positive side coming off my top load of my Van de Graaff generator. And that is the negative side, which is not connected to anything. The negative portion of this coming off the ground of the Van de Graaff generator, which is a wire, it goes right inside the little deal. There's usually a wire that comes with these that you could actually connect a high voltage probe to or something. That's your ground side. Anyway, that wire I've run through this Maxwell capacitor, which I'm not even sure all the numbers on there. I'll have to read it off later, but anyway, it's going through the negative side and it's going through the positive side out to this and going down. Look real close down there. There's some rails. In between the rails I got a block of styrofoam wrapped in aluminum tape. It basically acts like a Franklin bell as well. So essentially what's going on there, when it builds up a static charge on this plate and this ball goes over and hits that, it picks up that charge and goes over and discharges it on that plate, back and forth. And this negative line right here is going into this mess that I made over here to try to run a rotor that I made that is essentially a vitamin bottle that is full of styrofoam, because of styrofoam's triboelectric qualities. Also, that's the reason why I've got styrofoam inside of there. And then on the opposite side there's a jumper wire from this side to that side. Both of these are negative to run this side of the deal. Well, so far, because of the weight of them, and it takes a lot of real fine adjustments to try to get anything right, all I can do is get those to rock back and forth. My ultimate goal is to try to get them to spin. So I've got some other ideas on it, but in the meantime I'm running this right here and showing you how simple it is to make a what they call a Franklin bell. There's probably other ones out there like that. These little styrofoam pieces will get charged up, and whenever it's going, you can actually put your finger and watch them jump away from you, and these little styrofoam beads will actually climb up the wall of this. I had one that went all the way from the floor up the leg of the table and worked its way over and got on that rotor right there. It's really hard to do any videoing with it because the static spreads out so much that it interferes with this camera. But the reason why I threw this capacitor in there is because I wanted to show how easy it is to actually store that static charge in something like a capacitor and build up some charge. So I'm going to fire this thing up again, and I'm going to run it for a while, and the camera's probably going to get jumpy. I'm going to pause it for a second and then restart it. We get the camera reset, and then I'll start it up, and then I want to show you I got a spark gap on this side of the capacitor. I'm doing it, can't see both there. There's a spark gap right here, and there's a spark gap right there. And you can adjust these spark gaps for a longer arc across there, which will cause these to punch harder, and you can actually start to see these start to try to rock like they're trying to turn. But so far I haven't got no rotation out of it. Franklin bell works all right. So I will reset this and I'll fire this up, and then I want to show you how you can charge this capacitor with that static electricity and how much it actually charges with that static electricity. Alright, so stay tuned. Be right back. Okay, I'm back, and that's probably the closest I'm going to be able to get to it with the camera. For some reason this thing won't zoom. But I'm going to start this thing back up, and the camera's probably going to get jumpy as soon as the static builds up. So apologize for that. It's the best I can do for the moment. But what I wanted to show you is how I can transfer that static energy into that capacitor for later use. And hopefully, now that I've got the capacitor on there, you'll start seeing some more arcs coming off of those rotors right there where they're actually trying to kick over. And I'll get it worked out eventually. When I do, I'll make another video on that, because what I tried to show with that little aluminum piece right there on an earlier clip that I made, it didn't come out very well, was that aluminum covered in styrofoam covered in aluminum tape actually had a lot of attraction to that static charge, and so it would it had some torque to it. And even with that pendulum going on right there, there's a plastic ball inside there with aluminum tape on there, and you get that going pretty good over there. That literally starts to hit the side of that pretty good, where it starts to rock this wobbly table right here. And while you're watching all that going on, and you see this aluminum styrofoam block bouncing back and forth like the Franklin bell inside there, so you got motion going on there, you got motion going on there. That water bottle that was sitting on the back, you can see the water moving around inside the bottle there. And so there's a lot of potential energy in static electricity if it was used properly. And that's why I'm working with trying to build a really good static motor. And I believe part of it's going to have to do with some of the different materials that have different triboelectric effects, such as the styrofoam inside there, because styrofoam seems to want to attract to that static charge. So anyway, I'm going to plug this in and hopefully it fires right up. Sometimes that belt sticks and it won't go right out of the gate. Yay, I got lucky. You can already see that that aluminum block is moving. And I haven't started the Franklin bell yet, but you can see that inside there are styrofoam. It's now jumping around gathering up all that charge. And if I leave that long enough, that will literally, all that styrofoam, you can see when I put my hand in front of there, that it wants to get away from, I just got shocked, wants to get away from my finger, track to an opposite charge. So anyway, I put that in there for experimental purposes. You don't have to have that in your Franklin bell if you decide to make one. Just 2 aluminum plates or metal plates, either one. This one right here is your negative. That basically it's that wire. I just got it hit again. That wire is connected to that aluminum in there, so it's making it's conducting electric. Doggone, I can't even talk. It's connected directly to that wire going out. Alright, so I'm going to get this thing started now. There you go. Now you can see it's got electromotive force pulling that back and forth, and it's still trying to it's still moving that aluminum piece in the middle there. I don't know if you can see that from that angle, but let me move this camera a bit. See if this helps better. You can see that acting like a Franklin bell in between there. So it's going off the top load down there on the bottom. It's energizing that plate. It's putting a charge on that ball, which is discharging on that empty plate on that side. The electrons and flows going up that wire, down the alligator clip wire to this plate over here, which is a negative side, and that side has jumped over to that side, which is also a negative side. And so the whole concept is if I could get these rotors to start exchanging charges and getting them to spin. Well, let me back this up some here. See where we're at now. I can adjust this spark gap. I got it. See, it's arcing across from that doggone table down there. Alright. I better shorten that spark gap. Building up a charge down there. I don't even know how that's happening. It's going all the way from that table over to that little Dremel thing down there. See, it's so tricky because you move one thing just a hair and it makes a huge difference. I see what was going. There's aluminum tape down there. I'm trying to keep this doggone table away from all that. Alright, let's test the capacitor. I ain't had it running very long, but let's see if it's built up a charge. Sheesh! Ah! That was pretty good. Wasn't as loud as the one the other day. But you see, that was a pretty doggone good charge coming off that capacitor. That's a smaller one, less time. But it don't take long to build up a massive charge on this. Got to get these things adjusted just right. You can still see the aluminum block trying to pull. It hasn't built up enough charge yet. When you get in that field, it'll slow things down for a while. It all jumps to you. That's probably why it makes the camera do what it does. See, it don't take long to put energy into that capacitor. I got everything all out of whack now. Doggone it. See how ouch. See how easy it is to pump everything? It all needs to be hot glued. There it goes. Let that run for a bit. So it's moving to charge, and after it runs, the longer you let it run, you'll start seeing that these rotors will start creeping around. This one goes this way and this one goes that way. When the charge gets up higher, you'll start noticing that bell starts to go a lot faster as well. So my purpose for showing the capacitor being able to charge that needle up is because I'm working on some projects to where I actually believe that we can harness static electricity for on-demand usable power, and I honestly believe that we can get enough force out of static energy and guide that energy where you can see how just about anywhere you put your hand out here, including this table, I don't know if you can see that or not, but it's jumping across on that metal. Anything that's metal all the way around, or even stuff that's on the floor, and had an arc going across. There was a little piece of aluminum tape down there that was close to that leg, and it was jumping across to that little Dremel drill press deal. But if you could focus all that energy in one contained area where it couldn't have a chance to escape, you could get some serious torque out of these static motors. I don't know if you can see that or not, but it's arcing across to my finger. Anyway, I hope you enjoyed this video. I know it wasn't really all that exciting, but as far as physics toys, the Franklin Bell's one really simple project you can put together, and you can use a Van de Graaff generator, a Wimshurst generator, Lord Kelvin generator, any of the static electric deals. There's a Hawksby device out there, and also negative ion generators. And you can build small models of this to take teach kids at school, you know, about static electricity. And there's a lot of physics going on here, as far as you got a pendulum effect going, and you're actually getting some acoustic pressure when that thing slams against the side. If you look close enough, you can see this table's wobbling, that bottle of water back there is wobbling, and you can see, if you look close enough, the wire on the Van de Graaff generator is jumping back and forth. Every time there's a pulse, it'll jump back and forth. I can adjust these spark gaps to get more power to it, but for some reason I ain't got these things, I ain't been running it long enough, I guess. But it'll punch harder if you get it adjusted just right, and those little bottles will start to try to turn. So far I haven't got them to turn, but the ultimate goal is, because of the weight of those, I want to be able to make them turn, because I believe that I've seen rimstar.org do some videos with torque, and lid motor with static electricity stuff. I've seen them do it with some torque, and I think that can be improved on. I think you can expand on it using different materials that have different tribal electric qualities to either pick up a static charge or reject a static charge, one or two. and you can see it's I'm charging that capacitor, and that's some dangerous amount of voltage that's inside that capacitor. So if you're ever going to try these experiments, always be really super cautious with these capacitors, because they can really hurt you and maybe even kill you if they're charged up enough. So always practice electrical safety. Don't learn electrical safety by accident. And so with that said, you can see I'm getting motion in my water bottle, I'm getting motion down there, I'm getting motion over there, I'm getting motion right there. All of this with static electricity, and I'm actually able to charge up a capacitor. Now if I leave this running for about 20 or 30 minutes like I did the other day, I had an arc that came off this far, and that sounded like a shotgun going off whenever that thing. So I'm glad that I didn't accidentally touch that one. I probably wouldn't be talking to you right now. But anyway, I'm going to shut this down. I'm going to discharge that, and I'm going to give you a better look at that capacitor. And also, when you discharge these things, kind of maybe a little bit longer after you've already discharged it, either put you something solid on there, because sometimes these things have capability of literally coming back around and building up a little bit of a charge from the leftover static, and you don't want to get caught by surprise, because if you touch them things on the side. This is the capacitor that I'm using, and I can't really read the numbers on there. It says 0.02 UH on there, but all the numbers are pretty well rubbed off. It's Maxwell Technologies. I'm sure there's actually some sort of numbers inscribed on the back of this. I don't know if they're relevant, but if you can't see those either. Anyway, I haven't found a capacitor like it. I don't even know what they use them in, and I don't even know what the maximum volt range was. It just got it in an auction somewhere with a bunch of other stuff that I had, and there you go. I hope you enjoyed that video. That's the Franklin bell right there, and this is so far semi-fail electrostatic motor. I can get it to turn a little bit, but I can't get it to rotate completely. I had it at one point where it was moving about that slow, but the key was that it was actually moving. And even when it's just rocking back and forth like that, it's moving. Usually when that happens, I'll have it adjusted just right to where you start seeing arcs jump across from there to there and from there to there. And if I get these rails adjusted just right, then I can get it to actually do that. So if I get it to turn like I want it to turn, I will make another video and show you, because I believe it's possible to actually make a dual side-by-side static rotor system that one's going to turn that way and the other one's going to turn the opposite way, because they're trying to get to each other, but they can't because they're mounted down. Anyway, I hope you enjoyed the video. Peace and love, everybody. Take care.